This teacher believes that planning is essential for the development of worthwhile classroom activities. She is here preparing to guide her pupils in the study of plants. She selects from the local film library the sound motion picture Plant Growth because it will meet the interests which have been expressed by her pupils. The teacher is aided in her planning by suggestions found in the teacher's manual which accompanies the film. In a preview of the film, she finds connecting links to film showing.
You remember in our study of bees, we learned how insect life and plant growth are closely related. We were curious then to know how the bees carried pollen from one flower to another, the kind of flowers bees visit, and the conditions under which a seed grows into a plant. Now let us see how the film Plant Growth answers these questions. You'll probably find other questions you want to raise after you see the film.
Here is a flower in bloom. The bee, seeking nectar from the flower, gets the pollen grains on its body. Some of this pollen will be brushed off on the next flower it visits. After the pollen has fertilized the flower withers, and the pod grows to accommodate the growing seeds within.
But how do seeds start to grow? Are all seeds spread like the ones we saw?
Well, let's try to find out. Let's bring into class tomorrow as many different seeds as we can and find out how they are carried. I saw one this morning that had wings. Yes?
How long will seeds live if they're planted? In the film we saw the young plants die on the rock. But I know a place where plants grow on rocks.
Yes. Do you remember what the film said the plant needed in order to grow?
Why can't we plant in our room and see for ourselves what... We have a cactus plant at home. What does it have?
Now that's a question, Jack. And here's another. In what kind of country are cactus plants usually found? That leads us to a very interesting study. How plants are adapted to the place where they grow.
The physics class well along in their study of... They have already seen the film Sound Sources. This group is with harmonics. This one is studying frequencies. These pupils, sound does not carry through vacuum.
Does this mean for no air we would never hear any sound?
The first time we saw the picture, we learned about the sources of sound and how the world started. But since then, the class has asked many questions similar to you. Perhaps this would be a good time to see the film again and see the answer to questions. Causes sound waves to travel.
Sound wave impulses are carried by air molecules. The air is as the prongs of the fork spread out. As they spring back, a partial vacuum is formed. This results in outward moving condensations and rarefactions.
What type of sound source is the voice?
In the trachea and in the cavities of nose, mouth, and head are elastic columns of air which can be made to vibrate. The vibrating source is in the voice box and consists of two muscular strips called the vocal cords.
Why does music sometimes sound louder over water at night?
The portions of sound waves near the surface travel more slowly through the cooler air near the water. Their upper portions, that would normally be unheard, are bent down toward the surface, and the wave is thus focused and strengthened.
The richness of this direct teaching has led many of the pupils to explore unusual bypaths.
In the clarinet, the sound is caused by a vibrating column of air which becomes shorter when the player takes his fingers off these holes. Thus, the tone becomes higher, like this.
Other members of the class have measured distance by sound waves. Still others have charted how sound is recorded. And others have surveyed the acoustics of the school auditorium. Here is a general science class finishing a study of erosion. The pupils have seen the film Work of Rivers several times, each time for a specific purpose. Note the teacher's technique in taking advantage of the film's possibilities for the purpose of review.
Let's see the film again today to review what we have learned in our study of erosion. Perhaps some of you should pay special attention to the part of the film which shows how rivers are formed. After you've seen the film, I should like to have each of you write a summary of the most important ideas we've covered.
Today, as through long ages past, tremendous forces are at work tending to reduce all land to sea level. Were it not for great opposing forces, rivers would long since have brought all land to the level of the sea.
Here, the teacher turns off the sound of the film, and pupils describe scenes which the class has been studying.
This tiger eats raw meat. He misses his home in the jungle. His stripes would make him hard to see in the tall grass.
This caterpillar is spinning a strap. He keeps adding a strand of silk to it every time he moves his head across. This strap will help to hold him to the branch after he turns into a pupa.
This shows how lightning happens. The top part of this cloud has negative electricity and the bottom positive. The wind blows the top part off, leaving a strong positive charge just above the earth. By induction, the earth underneath becomes negative. When this charge gets strong enough, a great spark jumps across. This is lightning.
You remember when we studied oxidation and reduction last term? The film explained the chemical action of reducing agents on oxides. This week, in our study of metals, we plan to investigate the general topic of reducing ores to their metals. Let's review the film again to make sure we understand the general basic principles of reduction.
In this cross-section drawing, we see the furnace being filled with alternate layers. Another blast, rushing up from the bottom of the furnace, converts the coke into the gas, carbon monoxide. This removes the oxygen from the iron ore, reducing it to metallic iron. The continued intense heat melts the iron, which passes through to the bottom of the furnace and is drained off.
These classroom scenes have illustrated first the planning of the film lesson, including a careful study of the film to be used. Next, the way the teacher may introduce the film showing, and third, how the teacher may guide the discussion after each showing. This film has shown the sound motion picture may be used to initiate the unit, to assist the teacher in direct instruction, and to serve as a quick and accurate review. The many effective ways in which the educational sound film is being used suggest that the dynamic quality of this new medium in bringing a wide range of life experiences to the classroom its authentic and concise presentation by which it overcomes limitations of time and distance, and the facility with which it presents materials impossible to study, constitute an unrivaled opportunity for the creative teacher in modern education.